Welcome back to Chem Reactor. In today's video, we are going to discuss a commonly used solvent in academic as well as the industrial synthesis. That's a tert-Butyl Methyl ether. In short, it's a MTBE. This MTBE is a preferred choice by many process chemists over the diethyl ether. Personally, I also like to use MTBE compared to diethyl ether because of many reasons. But this MTBE comes with one of the major issues, that's hydrolysis in aqueous or the strong acids. So in today's video, we're going to see how does this works, what's the reaction and the mechanism, and how to avoid this. MTBE hydrolysis in aqueous or strong acids. This MTBE is extensively used in industry as a safer alternative to a diethyl ether because it has a higher boiling point. Here you can see that MTBE has a 55.2 degrees Celsius and diethyl ether 34.6 degrees Celsius. And also other reasons that MTBE is preferred over diethyl ether is it has a lower flammability, improved solubility, and less toxicity. And the most important point this MTBE has, or the advantage has, is the higher stability. Here MTBE don't form peroxides, but diethyl ethers in the presence of sunlight and aerial oxygen forms this highly explosive diethyl ether peroxides. I already discussed this how a peroxide and forms and the mechanism in another video. So these are the advantages that MTBE has over this diethyl ether. So that makes MTBE as a preferred choice over this diethyl ether in many chemical reactions or especially in the process chemistry. But this MTBE comes with one of the major problem. That's the instability towards the aqueous or strong acidic conditions. Here we use the MTBE in many chemical reactions, but sometimes if we're using strong acidic conditions, this MTBE can get hydrolyzed to this tert-Butanol and methanol. Here is the mechanism of MTBE hydrolysis. Here lone pair of electrons from MTBE abstracts this acidic proton and forms this oxonium ion. This step 1 is a reversible reaction. This can take back this oxonium to this MTBE again. Here in the next step, then this liberates this methanol and forms this tertiary carbocation, stable tertiary carbocation. This stable tertiary carbocation again reacts with this water molecule in the reaction medium and then forms this tert-Butanol. This is how this MTBE gets hydrolyzed to this tert-Butanol and methanol under these acidic conditions. Key takeaways from this video is avoid exposure of MTBE to aqueous or harsh acidic conditions. The second hydrolysis product of MTBE in aqueous or strong acidic conditions are tert-Butyl alcohol and methanol. These can react with your starting materials, intermediate, or the reagents in the reaction and can form additional impurities. So here in a small scale reactions or in academics, it's not an issue because we do a column purification. But if you are doing your process chemistry, then it's really important to avoid harsh acidic conditions in MTBE. Because in process chemist we cannot do column purification. Here you have to do filtration to get away or rid away of your impurities. And if your impurities form with this additional products formed from this tert-Butyl or tert-Butyl alcohol or the methanol can be an issue. To minimize this issue, we should avoid exposure of this MTBE chemical reactions to aqueous or strong acidic conditions that can prevent the hydrolysis of this MTBE. I hope you enjoyed the video, and please don't forget to like the video and subscribe the channel for more logical or the scientific updates on the chemical reactions or the chemistry. Thank you.